Hello and welcome to the ExCALIBUR program market engagement presentation. Today we will be speaking to you about the cross-cutting themes for the ExCALIBUR program and inviting you to help shape future calls developed from this activity. My name is Elizabeth Bent and I'm a Senior Portfolio Manager within EPSRC, and I'll be joined for this presentation by Nigel Wood from the Met Office, who will introduce himself later. So, Strategic Priorities Fund. The Strategic Priority Fund was launched in 2018 and is one of the UK's largest publicly funded programmes of work to spearhead multidisciplinary and interdisciplinary research and innovation. The scheme itself has funded 2 waves since 2018, with the ExCALIBUR programme falling into the second wave. Other programs funded through those 2 waves include 34 themes of multidisciplinary and interdisciplinary research. So since 2018, we've been able to build upon the vision that Sir Paul Nurse had for a common fund for multi and interdisciplinary research programs that previously was not available. So the official title for the ExCALIBUR program is the Harnessing Exascale Computing Strategic Priority Fund. Moving forward, you'll commonly hear our program referred to as ExCALIBUR. This is a 5-year program, and the delivery partners for this program are the Met Office, who operate on behalf of the PSREs, and EPSRC, who operate on behalf of UKRI partners. The aim of this project is to redesign high-priority simulation codes and algorithms to fully harness the power of future supercomputers, keeping UK research and development at the forefront of high-performance simulation science. So how will we actually achieve these aims? The objectives we have for the program are efficiency, capability, and expertise. By efficiency, we want to ensure that important scientific simulation codes will be able to harness the power of supercomputers of the mid-2020s and bring about an increase in scientific productivity for a given investment. Capability, we want to then capitalize on this efficiency, which will allow the UK and enable us to push boundaries of science across a range of fields, such as the simulation of bacterial process or multi-scale modeling for fusion. Finally, expertise. We want research software engineers to have progression and advance their career development within the ExCALIBUR program and position them as the next generation of UK software engineers at the cutting edge of scientific supercomputing. The 4 boxes that you can see on your screen are the pillars within the ExCALIBUR program. And these pillars are fundamental principles that guide the development of research for the ExCALIBUR program. And as you've probably read now, those pillars are separation of concerns, co-design, data science, investment in people. I mentioned briefly that the Met Office and EPSRC operate on the behalf of other partners, and so other partners involved in the ExCALIBUR program are the UK Atomic Energy Authority, STFC, NERC, and MRC. So the program delivery itself. The ExCALIBUR program has 5 tranches of activities across the 5 years of the program. Firstly, we have the RSC KI activity. So that's the Research Software Engineer Knowledge Integration activity. Sorry for the acronym. This is to advance the RSC profession and improve two-way flow of trained individuals between academia and industry. This will be run by UKRI. High priority use cases. This is research into a core set of simulation codes that span a wide range of science life. Currently, there are use cases funded by the Met Office, UK AEA are in the process, and UKRI have also funded use cases. The next activity is the emerging requirements for high performance algorithms. This is a chance for us to identify and develop high performance algorithms in areas of significant potential impact. Cross-cutting research, which we will be discussing later on in the presentation. And finally, the hardware enabling software tranche. This is a capital activity that allows us to support a number of innovative proof of concept systems and testing of new hardware for deployment at scale, and offers the opportunity for collaboration with industry and also for elements of the program that have already been funded and the wider community. That's your overview of the ExCALIBUR program. I will now hand over to Nigel, who will give you more detail on the use cases and the cross-cutting themes. Over to you, Nigel.
Thanks, Elizabeth. My name's Nigel Wood, and I'm the science lead for ExCALIBUR at the Met Office. As we've just heard, the two biggest themes of ExCALIBUR, means of delivery, are the use cases and the cross-cutting themes. At the moment, we have a number of activities up and running across the programme for the use cases. Within the public sector research establishment side, we've got 10 activities under the weather and climate prediction use case. Some of the areas there are indicated in the schematic. And then at the UK Atomic Energy Authority, the use case is the fusion modelling. And there are 8 activities up and running or about to be in that area, looking at a highly complex multi-scale system indicated in the diagram here. And then from UKRI, they have the 10 design development working groups that are listed here. I know not all of those are use cases. There are some that probably come better under the covering of cross-cutting themes, but many are use cases. I won't run through those. You can look at those yourself and read them, but they're covering a very wide range of topics, from things like high energy physics, particle physics, turbulent flow simulation, and continuum mechanics, so covering a very wide range of topics of interest to the UK simulation modelling community. So the use case aspects are in hand and underway. But what we want to spin up now is work under the cross-cutting themes. And it's probably worth starting by describing what we think we mean by what a cross-cutting theme is. So as the first few bullets explain here, it's an area where we need some coordinated approach across the community that will address known technology infrastructure issues that are barriers to us achieving performance on our X-scale machines of the future, and areas where their resolution will lead to significant progress across a range of such challenges and over a range of timescales. We imagine some we might be able to make some good progress relatively quickly, others we might be laying down the work that will deliver in several years' time. To be a cross-cutting theme, though, it really needs to be an area that will address multiple, at least more than two use cases. And for some of the themes, as you'll see on the next slide, some of our thoughts around what those themes might be could apply to all the use cases. For others, it might be that they apply only to those that are solving a particular class of equations. So, for example, fluid dynamics. The other aspect is we want the cross-cutting themes to be determined by the ExCALIBUR community as a whole, rather than just us sitting down and determining what those should be. The community needs to have input into determining what those are. And we also need to make sure that we're inclusive and aren't just looking to those working on the use cases to define what it is that we should be doing and what it is that we can be doing. So domain agnostic in a sense, though within the constraint of it being within the remit of the ExCALIBUR program. With all of that in mind and looking at workshops that we've run and engagement activities that we've previously done, then we consider there's probably two broad cross-cutting work packages. One is looking at the common approaches and solutions, so those things that we all rely on in the use case work, and some examples are on the next slide. And then another one is, we've struggled a little bit with what the terminology is, but for the moment we're calling them potential disruptors. So this is where new ideas, new either technology, new approaches to software or new algorithmic designs are coming along that will give us, have the potential to give us a step change in the our approach to exascale modeling. And so this is a list of ideas that we have had for themes, cross-cutting themes under the heading of common approaches and solutions. So we're thinking of things like input, output, getting data into a simulation system and getting it out again. There's then also data workflow, how that data is managed as it progresses through the simulation. Virtually all of the use cases that we're talking about are very complex systems that typically involve the bringing together of different modeling types within that system, and therefore those different models need to be coupled together, and how we do that coupling can be important to making sure that that data workflow that I've just spoken about proceeds in a smooth fashion and in a scalable way. There's an increasing element of domain-specific languages, the separation of concerns approach that was talked about earlier as one of the pillars of ExCALIBUR, as this is a way of making the simulation systems more agnostic to the specifics of the architecture of the supercomputer at any one time. And it feels like rather than each distinct area producing its own domain-specific languages, there may be groups of areas where we can collaborate and take advantage of commonalities between them. Fault tolerance is something that is likely to come to the fore with exascale machines, and there are doubtless good ways, bad ways of dealing with that, and the benefits of each of those is likely to be common across the use cases. So that seems like an area for cross-cutting work. Visualization, exascale simulations are going to produce a huge amount of data, and how we visualize that how we manage the data in order to visualize that is going to be a challenge. That may be appropriate for a cross-cutting theme. It would be interesting to garner people's thoughts on that. And another area that's coming to the fore is mixed precision, becoming increasingly important that we move as little memory around as possible, and that we only do the necessary calculations to get the accuracy that we require. And therefore this means being quite parsimonious in the accuracy with which we do the calculations. And again, this feels like an area that isn't going to be specific to just one use case. The other work package, as I say, we're calling potential disruptors. There's a number of areas here where we might see things coming along. So one is new algorithms that allow us to expose better parallelism within the simulation systems than we have hitherto been able to do. So things in mind there are things like parallel in time. There's new technology there, so things like containers, object stores, cloud tools that traditionally have not been used within the sort of systems that we're talking about within the use cases, and that it would be good to explore what the how we might capitalize on their benefits. Performance modeling. We are targeting machines that we don't know what they will look like at the moment, and we're trying to design algorithms to work efficiently on those. And so performance modeling might be a way of being able to achieve understanding of what those algorithms might be able to do. And again, these are things that are likely to be useful for more than just one use case. Machine learning for parameterizations, being able to speed up the parameterizations that we use through application of artificial intelligence machine learning is something that is surely of use to a particular use case, but it seems likely that for certain types, classes of solvers, then there might be some commonality there that we could explore as a cross-cutting theme. And then finally, it's important that we keep our eye on how the supercomputer architecture and the things around that are evolving as time progresses, so that we keep ahead of the game, if you like, aware of what's coming our way. So those are some thoughts we've had so far on what some cross-cutting themes might be within those two broad work packages. And I'll now hand back to Elizabeth to explain the process by which we would like to get your further engagement in helping us to shape those calls. Thank you.
So, what is the engagement opportunity? The aims behind this opportunity is to provide you, the community, with a chance to help us develop the cross-cutting research themes for this program. We currently fund use cases across the program, and we're aware of their capabilities, but we recognise that we need to understand the capabilities of the wider UK research organisation. We will then use this information you've provided us to help shape future calls for the cross-cutting research themes. So please, we ask that the breadth of the UKRI and PSRE research communities could share and contribute your thoughts on how you as a researcher or a research group may contribute to currently proposed cross-cutting themes, and then share input and your insight into any further cross-cutting themes that we should have considered or would be really beneficial to pushing us forward in preparation for exascale systems and software. We would like to note that your contribution to this exercise does not signify intent to submit. That is something that will follow on later in this process. How do you get involved? Please submit a 2-page document that includes your name, research organisation and area of expertise, the cross-cutting theme to which your idea applies. So you're not limited here. You can suggest cross-cutting themes that weren't included in this presentation, or you could choose to develop an idea shared in this presentation. Then we will ask you to also propose what activity could take place with the ideas you've proposed. And finally, we would ask you to consider the use cases or class of equations to which your activity would be beneficial. This last part is important for us so that we can ensure that there is integration across the program, and cross-cutting research themes is a great way to achieve this. Further details on how you can apply and the terms of this activity can be found in the guidance document. Finally, a thank you from Nigel and I for your attention. If you would like further information on the market engagement activity, you can access that via the web details on the slide. You can also contact us for more information via our email address, and please feel free to promote via social media as well. This activity is only live until the 4th of December, and we would ask that all submissions are sent to our email address by the 4th of December at 12 noon. Thank you again for your time. Bye-bye.